to take control of your account, to take control of your sales, you must be able to have some thoughts that you should be able to share with customer, give them some direction, and that is what we are going to learn about the databases in this session. So the basic technical solution, the most primitive one, the most widely existing technical solution and requirement, which is basically of relational databases. You need database which needs ACID compliance. It is an OLTP system, reads and writes happening, complex transactions. You write queries which involves joins. All these kind of systems are mostly popular among banks, among information management systems. Customer stories that you can, so if you are talking to customers and any of these things that you find these things resonating with your use case. So if you are talking to customers, they say, we need OLTP system. We need our database to be ACID compliant. We are looking for a database which is highly durable, or it supports normalized structure. If you hear about any of these cases, or if you hear about requirements which is similar to one of these, where we have a very large bank which is moving their core banking solution from Oracle to PostgreSQL. We have a very large bank, a very large insurance company in Singapore which is using Postgres as their default de facto platform. We have a large bank in Indonesia which is going to deploy EDB Postgres as their default platform for all the next gen applications. All their digital transformation related initiatives, they are deploying on EDB Postgres. So to such customers, you can give confidence by sharing these kind of customer stories. What does it take to get there? What features do you require from your database? So if these are the requirements from customer, what features should you be looking for? ACID compliance, built-in support for transactions. They should have complex transaction support. Your database should offer replication. It should offer high availability. It should offer concurrent access. Multiple people should be able to read the data. Even if someone is modifying the data, others should be able to read and read a consistent copy. These are some basic requirements from the most basic use case. So if these are the requirements that you are looking for, you should start talking about EDB Postgres to such customers. You should tell them that if you are looking for a fully ACID compliant database, EDB is there. It offers synchronous streaming replication. It offers cross-geography, multi-master replication setups. It also offers different kind of indexes. It also offers complex transactions. It offers very rich SQL support. So you can fire join queries, aggregation queries, all those things that you expect from a relational database, enterprise relational database like Oracle, are in EDB Postgres. So, and EDB provides tools for centralized monitoring, centralized backup. All these capabilities make it even more enterprise class. It can easily gel into your enterprise system. It can work on virtualized setups. It can work on physical environment. It can work in cloud environments. So deployment wise also you don't have a challenge. So if customers are looking for these features or these use cases, you should pitch them EDB Postgres. And these are primary features that you should share with them. This is one of the deployments we have done for a customer here in Singapore, the bank I was talking about, who is moving their core banking system. You have a primary database which is doing synchronous replication to a server. and it is doing asynchronous replication to another standby. So any transaction that is happening here is guaranteed to be committed on the second server as well. So always you will have 2 copies of your transaction, which is very important for banking kind of use cases. That is why you will pitch EDB in such cases. So every transaction has 2 copies, one on primary, one on the standby, is guaranteed. You have a third copy as well, but this is asynchronous, so it is not guaranteed. This is guaranteed. If this server goes down, this standby becomes primary, and your read-write queries will be over on this primary then. So this is a very classic use case where customers are looking for asset compliance, they are looking for durability of their transactions. So any transaction that they do should be durable, should be available on multiple systems, so that even if one system fails, transactions are available. So if, let's say, I withdraw some money and after that the database goes down, that transaction is still available here. Otherwise, I can go and withdraw again, right? In a bank, you don't want a system where people are withdrawing money and if database goes down, that transaction is lost. So my balance is back again to $1,000. And then I can go and withdraw 1,000 again. We all could benefit from that system. We all. The bank will not. Right? So banks want a system which is durable for their core transaction systems. Or system where you want multi-geography setup. Like MasterCard kind of people, they use these kind of systems. Where user registration happens by a global transaction manager, by a global load balancing facility, by DNS facility, their users get routed to a regional application server, which writes to the local database, and a user in another region will be routed to that region's data center, to that region's application and that region's database, and they replicate each to each other. And this happens this happens asynchronously, because we are talking about large geographies like America, Europe, Asia, so that is how their database systems are distributed. But eventually all this data also gets replicated here. So if the user travels to this data center, let's say I go to US on a trip, and if I try to log in, I will be routed to this application server, because then I'm in that zone. Because of the DNS routing, I'll be routed here. But by that time, my data also would have traveled here. So this is another use case where Enterprise DB is fantastic. These are use cases which have been implemented. So if these are kind of requirements customers are talking, you can immediately relate to Enterprise DB. Another use case, so this is another use case which customers would be talking about, ETL or BI tools. You have some kind of ETL requirement where you are transforming data from one system to another system. You are bringing data from multiple systems, putting them together and giving a report, right? Because banks have different systems, telcos have different systems, multiple systems, not just one application, right? That's how we all make money, because they are running more and more applications, so they are buying more software from us. But at some point of time, they want to combine all this data and see that together, or transform that data and transform into another system. In those use cases, you will see that common theme would be bulk operations. They want to do bulk read and bulk write. They want to have complex queries. These queries will allow you aggregation or joins. or convert data from one kind of format to another format. For example, they want to convert from relational format tables to XML or tables to JSON or from tables to flat files or Excel sheets. So extract data into Excel sheet, share with management for reports, or extract and then form PDF reports. These kind of systems would require that your database supports bulk and batch operations. Your database supports rich query language. Even if you can do batch operation in your database, but to query that data, you don't have proper language. You have to write very complex code. That is not a good database platform for doing ETL or for doing BI. It should be easy to represent your requirement, right? So another thing, especially if you're transforming from one format to another format, the model support for different models is important. Let's say you want to convert from relational to XML. If your database does not support XML, then you cannot do that. Then you have to rely on the ETL tool, which can be slow. A use case of this is which I and one of my colleagues implemented. We took data from source system, which is AS400 mainframe system, and we put it in staging in Postgres, in EDB Postgres, transformed that, and then we pushed that data into Couchbase, which is a NoSQL database. We use Postgres to convert that data from relational to JSON. Postgres supports both relational as well as JSON, so it was easy for us to do that. Postgres also supports bulk operations, so we could write a single select query that gets all the JSON documents, and then all we do is post. By HTTP post, we post everything to this database. So this is one of, and we use Pentaho as the orchestrator tool, as the ETL orchestrator. Another example my colleague implemented was to get data from legacy system for an insurance company, to get this data from their Life Asia system. It's a popular policy management solution, mainframe policy management solution, very popular in insurance domain, in Asia especially. It's called Life Asia. Get that data in Postgres, use Pentaho to again do the same task, transform that data and post it to the SFTP sites, from where it can be picked up by the bank. So all of you would have seen that banks also offer insurance policies, right? These banks at the back end, they partner with some other insurance company. In this case, the bank was always dealing with Excel sheets. They used to ask the insurance company to give them the list of policies. They would send Excel sheets and then they would go through that. But then that was not real time. That was also not something that they can combine with their system. So what they did was they introduced this ETL flow so that data can be exchanged between the bank and the insurance company on a regular basis in a seamless manner. So now their next step is to make it more real time, so that whenever there is a policy request, it goes here and data comes back instantaneously. Instead of batch, they will make it real time, so that bank can introduce a page in their net banking, in their internet banking. They will introduce a page where users can go and see their policy data as well. So now I don't have to log in into the policy system, into a separate login page. Next is mobile or offline data sync solution. How many of you use smartphone? Yes? Everyone? And what is the size of your storage on your smartphone today? 32 GB? 32 itself is quite a lot. 32, 64. Anyone who has less than 16 GB? Less than 16 GB on the mobile? No? Because when we buy phones today in Lazada, we go and apply a filter. Storage more than 16 GB. Right? That's how we buy. So we always look for memory with storage which is big enough. These are very fast machines that we carry that are portable with us today. If you go and talk to your customers, something that you can tell your customers as a thought leadership, going back to Sandeep's acronym of LOBART, you can bring that thought leadership to your customers that, hey, this is a very powerful device that you are carrying and your customers are carrying, that your sales agents are carrying. Can you leverage this? There are a lot of solutions wherein people want to have data available offline. When you use any mobile app and if it is slow, how many times do you feel that the app is very slow? Like when you are making a booking or when you are trying to buy something, if you see that the app is slow, it is not slow because your mobile is slow. Most of the time the app is slow because it is trying to download data. It is trying to download a lot of data from the internet. And if your internet is slow, it is going to hang because it is waiting for that data. What if that data was available on the mobile itself? If that data is available on the mobile itself, all that back and forth is going to be less. So your app will be faster. Now, we came across this application with two of our customers, one in Singapore, one in Indonesia, where the customer insurance company, their sales agent, they gave them iPads and told them you can go and sell policies by using this iPad. When I, as an agent, sit with a customer and take them through the whole form, you know what is the most painful thing about buying insurance? Except the policy premiums, which is money, which is always painful when you have to pay. But except that, what is the most painful thing?
To read it.
To read it, to fill up the form.
Yeah.
My name, my age, okay. Then, okay, employment details, now family details. Now, detail of each and every member in my family. Are we done already? No. We have some more details to be asked. Your health information. And it is even more irritating if I'm already a customer of certain insurance vendor and they're asking me all those details all over again. Dude, come on, why? Right? You get that feeling. So, they say that what we would do is, if you're going to meet Naveen tomorrow, you can download his data. If Naveen is already a customer, if I had sold some policy to Naveen in past, I can go and download his data which will be available on my iPad. Then I can meet Naveen. Hey Naveen, are you still single? Naveen says no, married. Okay, that is change. Are you still living in Singapore? Yes. Are you still with the same employer? Yes. What is your salary? Okay, I updated. Fine, let's go. And then I can show him the benefit illustration as well, which is done locally on the iPad, because all the product information also sits locally, because iPad is pretty powerful today. And then Naveen says, yeah, it's good, I want to buy it. I press OK. Customers sign it, buy. That is the only online operation, which is to buy the policy. Except that everything, filling up the form, all the product metadata, all that data is available in the mobile device. This is an amazing use case. applicable to all sort of customers who have offline requirements. Another great customer story of offline is Ryanair. Not that Ryan bought an airlines, but Ryanair is an airline in Europe, and they had this constant problem where customers would be waiting to book a ticket for eternity, and it will not be performing very well. So customers used to drop off. This is an actual revenue loss. So what they did is they started caching data offline. Things like airports, things like flights. A lot of that data can be cached offline. Only prices needs to be updated in real time when you're going to book. So because of this caching, they could improve their app performance by large. So you can talk to customers and tell them about these use cases, how they can make data offline available offline. GE, they have their field agents going on remote places to windmills and turbines where there is no internet connectivity to collect the data. They collect data from sensors offline. When they come back, their mobile device synchronizes and pushes the data to the data center. So if this is the kind of use case you are looking for, or if this is the kind of thoughts you are going to your customer and pitching them, have you thought about this kind of solutions? Your customer may get excited. So what kind of database requirements will you have? You will need some kind of data stored on the mobile device, right? So that your data can be accessed locally. You will need some kind of sync system so that the data can synchronize with the server-side database, and you will need a server-side database as well. There are different use cases. For example, e-commerce catalog can be made offline. What if your Lazada catalog was offline on your mobile? It will take some space, but imagine the speed of your Lazada app, or Redmart, or your news apps. If you have news apps, what if they can cache news articles offline? Whenever you are on Wi-Fi, they will cache the news article so that when you are in train or in commute, you can read through the news or hear the news. Or lead sharing, so that you can send leads to agents. If you think that I'm an agent and Naveen is a great prospect to pitch some kind of new insurance product or some new credit card, you can send it to me by doing some big data analytics, push it to my mobile device so that I receive that lead and then I can talk to him. I have all his details now on my mobile. So when I'm talking, when I'm going through different pages, different details, I don't have to wait. All the data is on my device now. All these use cases can be made possible by use of Couchbase or MongoDB. But I would not say MongoDB is my first preference for these kind of solutions. MongoDB is also document store. Couchbase is also document store. But Couchbase offers all the three components required here. It offers the server-side database. It offers this tool that can do data sync. It allows data from mobile to server and server to mobile. So it does this multi-master replication across multiple devices. And the database can be sharded. Like MongoDB, it also does horizontal scaling. Different way of doing replication, different way of sharding, but it also allows you to shard horizontally. So in those use cases, Couchbase is a great solution. So if you have any kind of requirement where you're thinking offline first or mobile offline solution, go and talk to your customers about Couchbase. And if you need any help from our side, let us know. There is a very large insurance company in Singapore which did this, and we can talk about it in detail. I can talk about the whole solution with you if you are interested in this. Let me know and we can catch offline more about it. The mobile database is supported on different mobile platforms. The server-side database is supported on different operating systems and cloud vendors. So you have full freedom. If you want to build an Android app or an iOS app, or if you want to use Xamarin as your platform to generate iOS or Android code, you can do that as well. Are we good so far? Any of these use cases click with you? Do you think you have customers who are looking for this kind of solution where they need ETL tool or they need some kind of new relational database? Are these use cases clicking with you? Yes?
Case one is especially.
Sorry?
Case one, how to generate report from many division which many
Okay.
database application. Case one. Very good with me.
Okay. And this mobile offline case, do you think you have any customer who is looking for this kind of data, this kind of solution, who might be interested? So what I would request all of you is when you go back, talk to your customers, tell them about these use cases. They might have thought about it, they might not have thought about it. So you can get a mind share with them. And if you need initially, if you're pitching it for the first time, if you need any kind of help or support from our end, feel free to ask for it. One of the KPIs by which my yearly performance gets measured is how many flights I have taken. So, keep me busy, invite me, and I'll go and talk to your customers. So, help me reach my KPI, help me take more flights. Okay? Another requirement is where customer needs document store. Imagine if they are trying to bring data from multiple systems, put all of them together and build something on top of that, on top of aggregated data. They need some kind of 360-degree view, or they are building something like a product catalog, or something like customer portfolio. All these use cases needs a flexible data store. So if you are talking to customer, they are saying we need a BI database which allows us to store data in a denormalized format, or we are going to store profile information where we need data to be stored. Each record could differ from each other because the information being stored in Philippines is going to be different for users in Indonesia. So help us, what kind of data store should we consider? The classic use cases of these are like United Airlines, Sprint, MetLife of MongoDB, a very large insurance company in Indonesia which is using MongoDB for storing profile information, a university in Singapore. What they did was, universities have a lot of learning systems, so they brought all these learning systems together because they were measuring different metrics of students in different systems. So professors have to go through each and every of them. What they thought is, why don't we bring all this together in one store and then we visualize it. So each system has its own structure, its own schema. How do you combine them? How do you correlate them together? So you need some kind of store which can store denormalized or flat structure. Usually what you need is flexible schema, horizontal scaling, because if you are trying to merge 10-20 systems, the data is going to be huge. Unless you're talking about 1 GB each, which is fine then. Otherwise, you'll need data store which is huge, which can store a huge amount of data. And you want to have query mechanism that allows you to query it in an easier way. Intuitive query. That is another thing that you want, right? MongoDB is a very good use case for such. This is a very good use case for MongoDB. It can shard, scale out horizontally. It allows indexes. It has very good query capability. You can use these. You can query based on different fields. You can aggregate like max, min, sorting. All these things are possible. Give me the salesperson who has sold most number of EDB subscriptions, or give me the salesperson who has sold most number of EDB subscriptions in Philippines. So all these kind of matrix sorting, all that you can get easily from MongoDB. It also has text search capability. So if you're doing like get me all the records where it is, get me all the records or all those songs which contains America, a free text search kind of thing. You can do that. Couchbase, another great platform for combining data, also supports JSON documents. You can shard. It has a language called N1QL. We call it nickel, not the nickel as in the money nickel. It is called N1QL, which is very powerful, which you can write queries like select star from or select some field from a table. Those kind of queries can be written in Couchbase by using nickel. It allows you to scale in a multi-dimensional way. So what are different dimensions of computers or of machines? One dimension is storage, another dimension is memory, another dimension is compute, right? 3 dimensions, right? Storage, memory, and compute. Usually, if you're scaling out, like with MongoDB, you will have to scale out all 3 of them. You will have to have similar kind of capacity on all the nodes. This is typically true for all NoSQL databases. Couchbase allows you to scale in different dimensions. You can have 3 data nodes. Let's say your data is 1 terabyte. You can store that in 3 nodes or 4 nodes. On those 4 nodes, you will invest on fast storage. So if you are thinking about AWS, you will have IO optimized instance. But then if you want to query a lot, or you have a lot of complex queries, you can have separate node which has very good compute power, 32 cores. Those 32 cores are not needed on all the 4 nodes, all the 4 data nodes. Only on one node which is doing computational tasks. So Couchbase has a different way of handling scale out. Then you can have another node which is high in memory because it is used for indexing. So you can have that node as index node. So it also has multi-client, multi-platform clients, same like MongoDB supports different drivers for different platforms. It also has this text search capability, though it is slightly newer, not so rich. ElasticSearch, which you can use for, again, sharded cluster of data, supports JSON. It supports very rich full text query. So if you are going to search a lot by keywords, ElasticSearch is a great database to aggregate your data. Let's say you're going to search a lot by transaction narration. So let's say you're building a system where you're going to store all the transactions from different applications. So you have one application for ATM, you have one application for card swipe, you have another application for teller, you have another application for internet banking. All these are doing transactions. You can bring all that transaction in ElasticSearch, and then you can allow users to search. Let's say they want to search by Starbucks. They can search by Starbucks, and all the transactions that were done at Starbucks will show up. If you have to implement that kind of query in relational databases with percentage, like, it will not scale. ElasticSearch is a fantastic data store for such kind of use cases. And this, I'm not trying to build a use case. There is a bank in Indonesia which is actually doing this. They are allowing their customers to tag transactions, and then those taggings are in turn useful for banks, for that bank to, Anubhav was talking about that use case, in turn to identify the kind of expenses and the kind of customer he is or she is. That is the use case Anubhav was talking yesterday, and that is backed by ElasticSearch. You can also do nice dashboarding on top of ElasticSearch database by using Kibana. Then real-time data analytics. If you want to do data analytics which is happening very quickly, if your customer says that, hey guys, I have heard you, but I'm actually looking for a system which is going to respond very quickly, which will respond within sub-millisecond or sub-second response. In such systems, the example of such system is like log data analytics. So if someone is trying to hack your system, you want to identify very quickly what is this person trying to do and block it. If there is a security breach, someone is trying to break into this room, and if I find out after he has broken into the room, there is no use. Right? He is already inside and he is going to kill me now. Right? So it is much useful if, while he is trying to unlock the room by using a wrong tap card or the wrong key, if I get to know that someone has tried wrong key multiple times, then I can send a guard here. Go to room 16, someone is trying to break in. Right? So if I can do that analytics in real time, only then that is useful. If someone is trying to do a credit card fraud, you have to analyze that in real time and stop it. Imagine I call up and tell you from your favorite bank, I call you and tell you, hey sir, you know what, yesterday $2,000 were charged on your card. We have realized now that it was not done by you, it was fraudulent, but we could not stop it. So you still have to pay your bill of $2,000. Meanwhile, we will investigate. Will you feel good about it? Citibank. I used to have a Citibank credit card when I was in India. I was traveling in Singapore at that time, and they sent me a message. So we have tried to block a transaction which was from Best Buy, which was happening at 2 p.m. India Standard Time. If you have not authorized this, please call us. So I called them and I told them I have not done it. They said, yes sir, we realized that by the pattern and we blocked it. And since you now acknowledge that it was not you, we are going to block your card as well because we think it is compromised. That is what needs to be done, and not after the transaction. Another bank in India, they called my friend and told him on the morning, sir, there was a transaction done yesterday. Someone booked for a flight by using your card for $200 and he is flying in like half an hour. And my friend can't do anything. We of course took it to the banking ombudsman and everything. We made sure that we did not have to pay for that amount, but it was a lot of hassle. If it was blocked like Citibank did for me, it was amazing. So you need To build that kind of system, what you need as a database is a data store which allows you to write and read very quickly, which has ways or allows you to express your complex queries, because finding frauds is not going to be like a select from table where category is fraud. No, it's not going to be a simple query. You will have to write some complex logic. So your database should allow that complex logic to be written and to retrieve data. MongoDB is a great choice again because it allows you to store data in memory-based storage engine, which is faster for read-write access. It allows you to express complex aggregate queries. It supports MapReduce, and it has a lot of query operators. And it can also push data to Hadoop, where you can do analytics and build the fraud model. You can build a model pattern which indicates if these are the criterias, the transaction is probably fraudulent. That is a model you can build in Hadoop, feed it back to MongoDB, and then in real time analyze transactions based on that model. So that is something you can easily do with MongoDB. With Couchbase as well, all those features that I talked about exist in Couchbase as well. Flexible data store, different type of data can be stored, can be fed into Hadoop. You can create indexes for faster access. It also has memory first architecture, which means any update that you do goes to memory first.
So just one question. So let's say take a bank perspective. Most of the data itself is actually stored in a transactional database. So how do you actually bring the data from the transactional database into Mongo or Hadoop to do all the real-time analytics?
So you would use some kind of ETL solution or a messaging solution.
So typically, what kind of solutions do you normally use to do this?
You would use like Pentaho or ESB, where data which is going into your transaction system also gets posted pretty much in real time to MongoDB.
Okay.
Or you would build a system which is sitting before your actual transaction system. So even before your transaction goes through, it goes via the system where it gets checked. So let's say you're trying to do a credit card transaction. So instead of directly hitting your main payment system, it's going to hit a secondary system where that transaction will be validated and then routed to that system. Got it.
Okay. Yeah.
So there are different ways of handling that.
Okay.
ElasticSearch also, let's say it is very useful for log analytics especially. So security events can be logged and can be handled in real time by ElasticSearch. So you can log all your log information, all your vulnerability information coming from different third-party systems into ElasticSearch, and then do analytics on top of that. It can be used by users. You can take real-time decisions. So you say that, okay, if login events are failing for more than 20 times, let us send an email to our user that, sir, you have failed 20 times. Is it really you or is it a bot? Is it someone trying to hack your account? Or if someone has failed to do, or if the utilization is going high, that is another use case of log analytics. If utilization is going high, let's increase the capacity, or send an SMS to our system admin. So all these are also examples of real-time analytics in the infrastructure management world, not in the end users world, but if let's say the customers you're working with, they're looking for this kind of real-time alerting and monitoring system, then ELK is a fantastic stack for that. Monica, who is my colleague, she's going to talk about it later. She'll be talking about ElasticSearch use case and ElasticSearch in a little bit more detail. Another solution wherein you are trying to build a modern application which needs some kind of caching or which needs faster data access. So you're building fault tolerant in-memory database, sub-millisecond access. These are some of the organizations who have achieved this either with Couchbase or MongoDB. Cox Enterprise or Expedia has done that with MongoDB. What you need is your database should support in-memory storage, and it should also have rich client library, which means it should allow you to write your application in Python or Java or .NET and still you can access your database. MongoDB is a great case. The one example that I talked about where you have in-memory database and you have some data which is getting stored on disk as well. Or use Couchbase. Couchbase has two different modes, Memcache and JSON. So either you can store your data as JSON or you can store your data in key value pairs, which makes Couchbase compatible with Memcache. So if your customers are planning of using Memcache, you can also talk to them about Couchbase and tell them you can also use Couchbase as a caching layer instead of Memcache. And Couchbase offers horizontal scaling as well as better durability by means of replication. So you get an enterprise level caching layer in Couchbase. Or you can cache your data, or you can tag your data according to the caching requirements with MongoDB and store them in in-memory storage engine as well. Now, how can Ashnik help you guys? I spoke through a lot of use cases. A lot of these use cases I have first-hand experience of either designing them or implementing them, or I have colleagues who have designed them or implemented them. I have first-hand experience of talking to customers about these kind of solutions, validating their requirement, coming back to my solution team and working on a solution with them. So if you are looking for a complex database solution, or you want us to go and talk to your customers along with you, give them confidence about any of these solutions, or if you have worked on a solution and you want to just, hey Samir, this is what I'm thinking, what do you think? Yeah, good. Or maybe there could be a challenge. So if you want to get our feedback on something that you're doing, any kind of assistance you need from our side, we are always there for you. Based on your RPO, RTO requirement, what is the best database solution? Based on your recovery requirements, based on your replication requirements, based on performance requirements, what is the best database you want? And the guys here have first-hand experience of doing things. So, your first project, you might not want to do it all by yourself. That is again where we can help you. And then second project onwards, you will have your confidence and you can do it all by yourself. So implementation help, pitching it to customer, designing the whole architecture, combining multiple pieces like what you asked, how to get data from different systems. So combining all those pieces together and building a solution. We can help you on all those aspects.